Press your hand into the desk in front of you. It presses back. The wood feels dense, permanent, and entirely solid. Our brains evolve to trust this sensation. The hard edge of a rock or the stability of the ground are signals of a safe world. For over 2,000 years, human intuition hasn't really changed. From the philosophers of ancient Greece until the end of the 19th century, we assumed matter was made of tiny, indestructible, and completely inert pieces of stuff. But that sense of safety is a complete illusion. The reality of what is actually happening inside your desk, your floor, and your own skin was shattered by a single, unremarkable-looking rock. In 1896, the French physicist Henri Becquerel was studying how minerals react to light. During a week of cloudy weather in Paris, he wrapped a sample of uranium in thick black paper and left it in the back of a dark drawer. When he finally opened that drawer, he found the photographic plates underneath the rock were heavily blackened. A ghostly burn mark sat in the center. The uranium had emitted a high-energy signal without sunlight, fire, or any chemical trigger. This single anomaly threatened the entire foundation of physics. Matter was not supposed to create energy out of nowhere. It meant a violent, invisible force was hiding inside the very structure of ordinary objects. To find the source of that energy, Ernest Rutherford began probing the physical limits of matter. He took a sheet of gold foil and hammered it until it was only a few hundred atoms thick, then began firing subatomic particles straight through it. If the physical world were truly solid, those particles should have bounced off the foil like hailstones on a roof. Instead, almost every single one sailed straight through. Rutherford had proved that the material world is overwhelmingly a vast empty void. His results only made sense if 99.99% of an atom's mass was crushed into a single microscopic speck at the absolute center. Matter appears solid only because we lack the resolution to see the emptiness between these points. This means the chair you are sitting on, the walls around you, and even your own hands are structural ghosts. True reality is dictated by the extreme physics happening inside that tiny, hyperdense center. Inside a uranium nucleus, 92 positively charged protons are crammed into a space only a few quadrillionths of a meter wide. Because like charges repel, the electromagnetic force is violently trying to push every one of those protons away from the others. The only reason the atom exists is the strong nuclear force, an invisible bond that operates over incredibly short distances to fiercely compress those protons together, barely keeping the internal repulsion in check. This internal tension is the physical reality of Albert Einstein's famous equation, E equals mc squared. The physical weight of that nucleus is literally frozen, compressed energy, held in place by the strongest force in nature. Uranium is uniquely dangerous because it exists right at the collapse limit. Its mass is a temporary, fragile balance between cosmic forces. It is a system stretched to its breaking point, vibrating on the edge of chaos. In 1938, physicist Lise Meitner realized exactly what happens when that internal balance finally snaps. The process starts when a single uncharged neutron drifts into the atom. Because it has no electric charge, it passes through the atom's empty void without resistance and strikes the vibrating uranium nucleus. The nucleus becomes unstable, stretches, and violently shatters. In that millionth of a second, a tiny fraction of the physical mass disappears, converting directly into a blinding release of raw energy. The split releases more than just heat. It fires out 2 or 3 new neutrons at 20,000 kilometers per second, which immediately slam into the uranium nuclei surrounding them. This creates an exponential cascade. One split causes 2, then 4, 8, and eventually trillions of reactions in a tiny fraction of a second. This is the nuclear chain reaction. Humanity merely learned how to activate a process that was already built into the structure of atoms. We found a way to trigger the devastating physics that the universe has hidden in every piece of matter since the beginning. J. Robert Oppenheimer and the Manhattan Project took these abstract blackboard equations and forced them into a physical reality. The explosion that destroyed Hiroshima was fueled by 64 kilograms of uranium, but the actual amount of matter that converted into energy was less than a single gram. That tiny amount was enough to level a city. This was the first time we saw the invisible consequence of subatomic physics, radiation. High-speed neutrons and gamma rays quietly pass through human cells, breaking apart the chemical bonds of our DNA and proving that our biology is helpless against these fundamental forces. Hiroshima permanently ended the long-standing illusion of safety. Ordinary matter was no longer seen as inert or reliable. It was proven to be a container for unprecedented cosmic destruction. The same physics that destroyed a city also powers the stars. The conversion of mass into energy is the engine of the universe, radiating the light and heat that allow the solar system to exist. Without the violent nuclear reactions happening inside the sun's core, Earth would be a dark frozen rock drifting through a void. We are kept alive by a relentless nuclear furnace 150 million kilometers away. Even the atoms that make up your body, the carbon in your blood and the iron in your cells, were forged inside the violent cores of ancient dying stars. We are physically connected to this chaotic physics. The reality that we live in is not a stable stage, but a fragile balance of quantum forces. Uranium was the catalyst that forced us to recognize the true, violent nature of the physical world. It showed us that we live in a universe far stranger than our intuition can understand.